Okay, I think we're going to get started. So quick introduction, my name is Chris. I lead the game tech organization at AWS. And today we're talking all about Amazon GameLift streams. This helps you stream your game to players at low latency all around the world. But the actual stars of today's talk are the individuals to my left. So we got Neela from Xsolla, we got Alex from Epic, we got Asa from Ludeo, and we got Evan from Jackbox Games. And they're going to talk all about streams and how they've built cool stuff. If you haven't heard of streams, or maybe you're encountering game streaming for the first time, what do we mean by game streaming? For one, it has these two important properties to it. It's both real-time and interactive. So real-time in the sense that the video you're looking at was generated milliseconds ago, and interactive in the sense that you're pressing buttons or you're moving your mouse and keyboard, and that's changing the state of the game on the other end, which then, of course, updates the video and is relayed back to you, and you kind of have this loop. So if you think of something like YouTube or Netflix, that's not really real time, right? That's sort of pre-recorded video that's streamed down to your client that you can cache, and if there's network interruption or latency, you just play out of the cache. Twitch is another example. That is real time, like it's recorded and sent to you, or a second or two ago. But it's not really interactive. Like, short of convincing the streamer to do something in chat, you can't really change the state of the game. So game streaming combines these two things. Game streaming is also typically something you want to get out to a breadth of players, or your place testers, or your QA, right? It's not typically just for a small number of players. It's thousands or tens of thousands of players that you're trying to engage with your back catalog, or your demos, or your playtests. You also have a breadth of content. So again, you're not typically just testing one version of your game or demoing one game or one version of your game. It's many, many different copies of your game, or different games entirely. You put these two things together and you get quite a bit of scale from game streaming, both a breadth of players and a breadth of content. There's a couple big challenges that arise anytime you try to build your own streaming system or you try to use something like this. They're technical and business challenges. The first one that comes to mind is probably latency, right? So you have latency at all layers of the stack that you have to detect and minimize, like latency in the runtime environment, in the file system, in the encoder, on the thing that puts the bits on the wire, and the transport layer, and the network itself. And then on the other end, decoding the bits and rendering them. And there's latency in the monitor you're using to look at the image, and then the controller you're using to send the command, the inputs over. And so these are all sources of latency that when you're building something like this, you have to detect and then minimize and keep track of. Another technical challenge is just the amount of infrastructure you have to keep track of. A good way to reduce latency is to push the GPUs where your players are. And it turns out your players are all over the place. And so now you have these GPUs at the edge. You have to maintain the life cycle of them, spinning them up and down, scaling them. You also have to keep track of sessions, right? When they stop, when they start. If they're AFK, you can terminate them, so you kind of control your costs. You also need to build something where you can sort of inspect and interrogate and improve the streaming quality, so you can determine if you're giving your players a good experience. So, did the stream have a dropped frame? Is it dropping the resolution? Is it a black screen? Did it start up in the right amount of time? You got to build all these things so you know if you're delivering a good experience. On the business side, it's complicated. So you have to hire a team of experts that know a bunch of different spaces, like graphics and encoding, codecs, low-level kernel stuff, networking, infrastructure, client SDKs, how a bunch of different devices work, and TVs, and a whole bunch of things. That's like the team that's required to kind of construct a pretty good streaming service. There's also things related to business in terms of controlling your cost and how that fits into your existing business models. So something we do at Amazon is we work backwards from customers. We talk to a lot of game developers, and we took these technical and business challenges, and we worked on them for many years. And a couple of weeks ago, we launched this entirely new capability called Amazon GameLift Streams. It lets you take your game and stream it to players all around the world. And you can do that at 1080p and 60 frames per second. And one cool thing is you don't have to modify your game to get started. You kind of just upload it, and in a couple minutes, you can probably get some streaming going. There's a couple things you get out of the box that help you. You can choose from 6 different GPU configurations, so you can determine how much rendering power you need. You can trade off between quality and cost. There's also 3 different runtimes, so you can bring something that's natively built in Windows or Linux, or you can use Proton, so you can emulate your Windows game, but on a Linux runtime. That helps you reduce your cost. Any engine is supported. So if you built something on Unreal, Unity, your own custom engine, you can bring that. Again, you don't have to modify it to get started. The way Streams works is it essentially it streams to any web RTC-enabled browser. And it turns out there's a lot of those. A lot of devices support that. You more than likely have literally something in your hand right now or on your person that you can stream to. So TVs and computers and tablets and whatnot. A couple of cool things that Streams let you do, and I think a summary here is it enables you to build a direct distribution channel to your players. You could pop out your own storefront with your content on it and start streaming directly to players. And you can entirely control and curate that experience in its entirety. You can create on-demand demos. Like a lot of games these days are, I remember when games were like 10 megabytes, but now they're like hundreds of gigabytes. And that takes time to download and for players to get into your game. So you could make a demo that's a minute, 2 long, an hour long, the first level, the first boss battle, and you can get players into your game in seconds into that sort of core gameplay loop so they can try it. You can stream your back catalog. You can stream 1 game, 100 games, 200 games, anything you want. Another cool use case that customers are using Streams for is secure and fast playtesting. So if you have a remote QA team or a remote playtest team, instead of them waking up in the morning and spend the first hour or two downloading the latest build and then getting set up, you can just send them a link and they can get started right into the game. I'm kind of going to pass the mic. I'm kind of blathering on, but the next up, I think, is Evan, right, from Jackbox. So I'm going to pass the mic to Evan. Everybody, welcome.
Thanks. I haven't done anything yet. I hope that was clapping for Chris. Thanks, Chris. So hi, I'm Evan Jacover. I'm the CTO at Jackbox Games. Really excited to be here. Thanks to Amazon. So just before we get started, who here is familiar with Jackbox Games? Okay, good. Enough people that aren't familiar that I can still show these slides because I don't know how to skip them really anyway. All right, well, we're best known for making games, party games. And we've been doing this for over a decade now. Some of our most popular games are Quiplash, Trivia Murder Party, Fibbage, including an extra large version of Fibbage. But we actually have a catalog of over 50 party games, and each of them has a glorious icon. And some of them are very popular, some of them are played less. We've, over the years, developed a pretty big fan base for these games. And for those of you who didn't raise your hand, our games all generally work the same way. You gather your friends together, you put the game on a TV somehow, and everyone usually takes out a mobile device and goes to the website jackbox.tv. The screen will show a 4-letter room code, and then on your phone you could put in the same room code and you're connected to the game, and everyone in the room is playing along. That's kind of our thing, and that's how all 50-some plus games in our back catalog work. So I'm going to take you through a little bit of our journey, why we were interested in game streaming and how we approached it as a business. The main reason we wanted to pursue streaming is to grow our business, which isn't a big surprise. But one of our strategies over time has been to get on as many platforms as we can. We want to meet people where they are. Our games are casual games, so we're not generally targeting the hardcore gamer. So by putting our games on all sorts of different platforms, we might meet someone who doesn't have a PS5 or the latest generation of game console and still wants to play our games. If you look at even our first 3 party packs, we used art that made our games look like board games, and there's a reason for that. We feel like our games are kind of more like board games than video games. And so we want to target those people who gather around with their family and take out Scattergories and Taboo and games like that and play and have some laughs and make some memories with their friends. And those, since that's our target audience, that's where we're trying to to meet our users. And this is what it looks like. Here they are. Most people play our games gathered together. They, I guess, celebrate Christmas all year round, and put the game on the TV and take out their phones and play. So while there's a lot of gaming consoles out there in the world, there are even more TVs, and nearly all the TVs sold today are smart TVs. You could probably kind of guess where this is going. And for those of you who like charts, here is that in chart form. You can see there's tons of smart TVs out there in the world, and even the other top two categories, Roku and Fire TV, are kind of these low-powered devices. They're not necessarily known for gaming. And, you know, you could search the internet and find all sorts of different charts, but I think even just in your day-to-day life, you probably kind of recognize this as well. And even in a single home, you might have several smart TVs, but only the one in the basement's the one that has the PS5 hooked up to it. And maybe you want to gather with your friends in the living room or something like that. So we started asking ourselves this question: how do we get our games on these devices? How do we reach these people where they are, where they're gathered around in the living room, eating snacks and playing games? So when we started looking into this and talking to these TV manufacturers, we kind of started having a lot of the same conversations. Can you port your game to be a web application? It's like, well, I guess maybe we can, but that's a lot of work, and we have a lot of games, and it's probably not going to be the same experience or even as good experience as what we've developed for our games the way they work now. Often we're asked, well, can you port your games to run natively on our devices operating system, whatever that is? And as again, we're kind of in the same situation. Maybe we could do it, but these tend to be low-powered devices, not a lot of memory, not a lot of storage, not a very powerful CPU or GPU. And then, we kind of came to this conclusion, well, maybe we could stream the game from the cloud. And that seemed like the best possibility given our large catalog and the technical limitations of these devices. So naturally, we started asking ourselves this question: how do we stream our games from the cloud? And our first step was, how hard could it be? Maybe we could build our own streaming technology, and we started to go down that path. And I think Chris did a good job explaining why we, as a small independent game developer, don't really want to go down that path. Even if we could get it working, to get it working well and efficiently is not our area of expertise, and to try to gain that area of expertise would not be the best use of our time. We just want to make games. That's what we're good at. We looked at other streaming vendors. There's a lot of them out there, and some of them might have been viable partners for us. But when it comes, our whole infrastructure is on Amazon, and we'd love to use a partner that we trust and we know a little bit about. And when we were talking to other vendors, none of them really felt like a great fit. So we already have a Jackbox Games channel on Luna, and it performs really well for us financially, and it works really well technically. And so we knew that someone somewhere at Amazon knows how to stream games. We just didn't really know who they were and how to find them. And so we talked to the Luna team, and we were like, hey, if we wanted to do our own streaming type of thing, is there anyone at Amazon we could talk to? And they said, well, actually, we're just getting started on it, but there is. And luckily, they connected us to the GameLift Streams team, and that's how we started on this whole journey. So just a little bit of a step back. Our intention isn't really to build a streaming service to compete with Luna. Luna does great. We think they complement each other. One of the things we're really excited about is having control over our own platform and building something that really provides the best experience for Jackbox games and for our users. And for this particular type of game we make, where you're using your phone as a controller and they're party games and you're gathered with friends, Luna's targeting all sorts of games and all sorts of audiences, and we want to build a platform that is specifically for our audience. So we started doing due diligence on this new streaming service, and the first thing we had to do was check and see, hey, can this thing stream our games? We're on our own custom engine, and so that was a deal breaker in a lot of situations. And it turned out, yeah, GameLift streams could stream our games. Good, check that one off. The second step is, can you stream our games at a low cost? This is probably the biggest factor for us. If we're going to get our games out there to an audience, we need to be able to charge a reasonable fee or find some way to make more money than we are spending on streaming the game to that user. Really, we just needed to get the price down, and no fancy features, just cheaper. And I really can't overemphasize how important it is to get these prices down as low as possible. Really, this is the make or break factor for our business here, for this endeavor we're on. So let's talk about price a little bit. One great thing is we've worked with AWS for a long time. We know they have a history of bringing prices down as products mature. We've used EC2 for a long time, over a decade, and we've seen the prices for running those servers come down and down and down and get more and more powerful over the years. And we have a lot of confidence that with this service, we will see something similar. It's been great working with the Amazon GameLift Streams team. We've, from the beginning, made it clear that what our issues were, and the team has worked with us to increase multi-tenancy, to have more games running on an instance. Our games aren't big AAA titles that consume a lot of resources. They're pretty simple. We've gotten them to run on lower powered devices, so we know we could get hopefully more than 1 or 2 or 4 or 6 instances of a game to run on a single GPU. And GameLift has worked with us to make sure that is possible, and with the roadmap in the future, get even more efficient with how many games we can run. Another nice thing is bandwidth is included. When we first started looking into doing this ourselves, we did a quick calculation for how much bandwidth costs to play a game, and it's not insignificant. And just being able to cross that off of our list of concerns was a big plus for us. And finally, the Streams team has worked to really improve just-in-time scaling. I think when we first started working, it was maybe tens of minutes to add more capacity, and now that's down to, I don't know how it's advertised, but it ends up being like a minute. So don't quote me on that, but in reality, for our situation, it's pretty fast, and something we could, if we had to, cover up with whatever we need to, instead of just being like, well, you're out of luck, we're out of capacity, so you're gonna have to wait 15 minutes for more to come online. Implementation, we started building out this product. I wish I could tell you stories about how complicated it was to get streaming work, but it just kind of worked. I was expecting, we often take bets of like, how many tries is it gonna take to like get this thing to build or get this thing to work? And we uploaded a build of our game, clicked the buttons, and it showed up. I was 100% expecting a black screen, and I was a little disappointed, to be honest. I may have lost some money, I don't remember. No audio, no audio glitches. It was really surprising. To make this work, as far as monetization is concerned, we're working on getting ads into our games. So the intention is to build a free ad-supported version of our games that gives you at least access to some of our catalog. And as time goes on, we're hoping to build that out and have a subscription access to our entire catalog. But right now, we want to show that ad revenue can cover the cost of streaming. And to do that, GameStreams has a feature called data channels, and that allows us to send messages from the game to our streaming client and back again. And that allowed us to implement ads very quickly. We could just send a message from the game that says, here's a good time to play an ad. We don't want to just randomly stop the game because you've played for 10 minutes and show an ad. We want to find a natural break in the action. And so we've put those breaks into all our games. We play an ad, and then when the ad is done, we send a message back to the game that says the ad is complete. Go ahead and continue playing. And this has worked really well and has been a nice, elegant way to get ads into our games. We also didn't want to scale capacity for each of our games individually because it's just not very cost effective. If we had to have 50 individual, if we had to have excess capacity for each of our games individually, that means some of our games that never get played would just have to have capacity waiting in case someone chose to play them, and some of our games that got played a lot would have to have excess capacity, and we wouldn't recoup any of that that excess capacity for the specifically for the games that got played a lot. And so working with the streams team, we were able to put all of our games into a single bucket, a single stream group. And so we can scale all of that capacity regardless of what game you're playing. And that allows us to really reduce costs by being more efficient as well. Again, like the reducing costs has been our main focus. And so it's been great to be able to work with the streams team on that. So now we're excited. We have our little baby game streaming service approaching beta. This is kind of what it looks like right now. And we can't wait for all of you to try it out. We're going to start with a handful of games. We have 5 games that are running right now. And this kind of works. You pick a game, you start it, you watch an ad. This is obviously just a YouTube screenshot, but it really shows the ads. You probably DoorDash some French fries because the ad was so effective. And then you're in your game. And you could play a game on your smart TV just like you would play, and it's as high quality as you would get playing on the fanciest console or gaming PC available. And so that's what we're doing. So what's next for us? Well, we're going to roll out this free tier beta with 5 rotating games as soon as we can. After that, we're hoping to add a subscription tier that gives you access to our entire catalog. And then there's all these features we're really excited about implementing that we could only do with the streaming service. And I'm not going to talk about those today, but I will be talking about tomorrow at 2:30. So if you'd like to hear more in depth about this, what we're building, I'm happy to share more tomorrow. So thank you to AWS for having us here, and got some other exciting case studies coming up.
Right on. Thank you. Thank you, Evan. All right, we got Alex next. Come on up.
All right, thanks, Chris. My name is Alex Carberry. I'm a director of technical product management at Epic Games, where I've spent the last 9 years across various roles supporting our business and our content creators. Today, I'm here to present on behalf of my team for how we're exploring using GameLift streams to evolve our core iteration loops and our playtesting capabilities. As you would probably all agree, the landscape for interactive entertainment is evolving at a pretty unprecedented pace. The complexities feels like it's growing exponentially every year. But one critical factor in successful development seems to be quick and efficient feedback loops between our creators and our users. Right? Getting the game out in front of our users, getting their feedback, how it performs, how it feels, how gameplay feels, etc. And the faster we can get this feedback, the more effective we can iterate and improve. And in a post-COVID world, this has become pretty challenging. So let me talk a little bit about the traditional playtesting landscape and really what I mean by playtesting. I know many teams have pretty specific definitions for playtesting. I'm just using it in a general sense to describe the process of generating feedback once an artifact has been created, a build artifact has been created. So this could involve QA downloading the latest build and running through their tests. It could be an internal company playtest, or it could be a more rigorously scheduled and controlled end user playtest or user research. all variations of which come with some challenges that all make rapid iteration and aggregating feedback quickly challenging. Some more than others, but holistically there are 4 bottlenecks that seem to apply across the board. Scalability, artifact distribution, secure and consistent configuration, and data collection. Limited space, hardware, and manual setup configuration steps restrict the scale that you can generally get diverse and unique feedback. Large build sizes and geographical elements and speed of light challenges introduce long download times and thus long periods of unproductive, I'm sitting and waiting for my build to download. Inconsistent and insecure security configurations limit the audience for pre-release content while also increasing the complexity of troubleshooting. And the complexity of troubleshooting isn't made any easier because a lot of the feedback is anecdotal and the process of gathering data is fairly manual. So while playtesting has undeniable value, its effectiveness is sort of limited when you look at it in a traditional sense. And when we look at it from a key business value standpoint and the things that we're looking to deliver, there are some quantifiable areas that we'd love to improve upon. Make the most of our playtesters' time, honestly. And probably most importantly, we want to also improve. We want to playtest and provide feedback on more than 1 or 2 of the probably dozens of builds we generate every day. So there's a lot of room for improvement. And when we examined these challenges, it became pretty clear that we needed to fundamentally transform how we thought about offering and hosting playtesting. And we needed to not just iterate and incrementally improve, we really need to look at how do we eliminate some of these inefficient workloads and workflows, which is what made the idea of game streaming and using GameLift streams so appealing. Theoretically, it eliminated a lot of these inefficient workflows for free. It unlocked scale without the traditional hardware constraints. There was no more procuring and maintaining and then eventually replacing physical machines. We could support hundreds of concurrent sessions, dynamically allocating resources based on actual demand. Theoretically, it eliminates the traditional geographic and time-consuming downloads. Anyone with a web browser can instantly access our latest builds, regardless of their local setup. And this global accessibility isn't just convenient, it's really a requirement now, given our distributed teams and our distributed users. And then finally, this shift theoretically would bring unprecedented control and efficiency. We would be able to maintain one source of truth for our builds. We'd be able to ensure consistent test environments, and we'd gain detailed insights into every single session, all while significantly reducing our operational overhead and our CapEx infrastructure costs. So all of that sounds great. Like, what are we missing? Enter the POC. Before we really got started, we sat down with the team and thought about what does success look like technically. The key requirement, the linchpin, if you will, which I haven't touched on at all, is performance. Fortnite is a game that's competitive. And so we recognized we had to get Fortnite successfully running on GameLift streams, and we had to validate the platform's capability to handle competitive gaming. We could have sat down and defined some complex quantitative metrics, but we ultimately landed on the best measurement being our ability to get a victory royale playing through GameLift streams. We had no delusions that GameLift streams was going to make me a better gamer, but as long as it felt competitive and it felt good to play, that was good enough. After that, we focused on 3 additional technical areas. First, we needed and wanted to validate that we could integrate with our existing build deployment processes and confirm that we knew how to integrate with our build pipeline. We needed to be able to quickly and easily onboard new build versions into the system and make them available to the team. Second, we needed to streamline the administration interface that would allow our playtesting team to manage everything from test personas to session scaling, region availability. There are a lot of different scenarios that the teams run through in playtesting, so we wanted to be able to expose a lot of complexity on demand in a way that our teams could self-manage in the system. And then finally, we had to validate an automated data collection pipeline that fed game logs and screen captures directly into a system that our developers could then use when they were trying to diagnose or troubleshoot issues, bugs. As we dove into our POC, we pretty quickly realized how much GameLift streams actually simplified our architecture and how many of the inefficient data flows it eliminated. On the left-hand side of the slide, you can see our traditional playtesting architecture. It's drastically simplified, but you can see how the build farm automatically uploads builds into multiple different storage appliances, how the users then have to go and all individually download those files, potentially spending 10, 20, 30 minutes just sitting idle while download's completed. All of our playtesters had to be on gaming PCs, no laptops, no tablets, no mobile devices. None of that would support Fortnite. And then realistically, all of their hardware was slightly different. So different hardware, different drivers, different configuration. And then finally, when, as playtest was complete, they were manually creating bug reports and uploading build artifacts. On the right-hand side, you can see the simplified architecture using GameLift streams. We still have our build farm automatically uploading builds and new versions into GameLift streams. You can see our admin dashboard that we created, where the playtest team was able to manually but universally define personas and configs. And then once they had defined a playtest, they could send a link out to anyone on any device, laptops, gaming PCs, potentially mobile devices, and they could all jump right into the game in seconds, saving probably dozens, if not hundreds of man hours in aggregate, just no longer having to wait for downloads. And then at the end of the game session, all of their logs and screenshots were automatically uploaded into a system that our developers could then reference. And so at the end, coming back to some of our success criteria, the short version is we hit it all. We got our victory royale. We set up our admin dashboard, and we successfully validated that we could integrate and improve on existing data flows, both in our build process and our process of capturing playtest artifacts. So what does that actually mean from like a quality of life standpoint, right? From a business standpoint. So for QA operations, we saw value in standardized environments and centralized data collection. For our internal playtests, we validated the potential for eliminating geographic barriers and increasing playtest frequency. We also saw increased participation. We had a surprising number of people who didn't have gaming PCs, didn't know how to participate in playtests, and so here's a link. It became a very attractive way to play. And then finally, for external tests, we confirmed the ability to provide controlled access to pre-release content while still maintaining security. And coming back to our business metrics, the impact was pretty clear. Setup time dropped from over 10 minutes to near instant access. We moved from highly manual processes to automated, standardized operations and controlled environments. And more importantly, we doubled the number of builds we could play test in a single day, marking a pretty successful conclusion to our POC, and generating quite a bit of excitement at what could come next. So thank you, and Chris, back to you.
Thank you, Alex. Next we have Neela. Come on up.
Just give me 1 second. Let me get set up. All right, we'll get started anyway. Perfect. Hi, I'm Neela Das, and I am a believer. I'm a true believer that cloud gaming is the first step towards the future of gaming. My background is I've been in the industry for over a couple of decades. I've worked in different, just give me a second. Yeah. So I've worked in the industry for over a couple of years, worked developer on the programming side of things, engine side of things, middleware, cloud gaming at Intel and Xsolla as well. So Xsolla, we're a video game commerce company, helping developers to monetize, distribute, and scale their games. All 1,000 of us are located all over the world, and we've been in business for over 2 decades. So we come at cloud gaming sideways, different than other people do. So we offer a B2B service to developers to bring their games to the cloud via a browser. One differentiator we have is using a pay-as-you-go monetization models. So users pay to play per minute. And another differentiator we have is a back-end of vendor aggregation working with multiple infrastructure providers. So this is our solution. There is no dev work. Devs simply upload their bill through a portal. And one of the great things is that it is free to launch. The price players pay can cover the costs. And we actually let developers determine that price. So let's look at it in action. So in building out this solution, we had a couple of annoying challenges. The first challenge was getting access to diverse hardware and being able to scale. The reason why that is important is that the backbone of Xsolla Cloud Gaming is an interconnected web of multiple cloud game streams and infrastructure providers. This architecture gives publishers and users access to more regions and hardware choices. So how does that benefit all of you? It makes it easier for users to access your game no matter what machine they're playing on or where they are located. So achieving this particular dream is not easy. And finding the right partner with this wide range of hardware specs and scalability to deliver this experience actually proved really quite difficult. And challenge number 2 was about providing a seamless service for the best developer and user experience. That's actually Xsolla's North Star. Another thing that makes Xsolla's solution unique is developers can access all of Xsolla's direct-to-consumer tools and platform capabilities through an easy-to-use self-service portal called Xsolla Publisher Account. And you can easily, as you can see here, drag and drop your game zip files or APK very quickly, launch your game in the cloud. Now, as you can imagine, finding the right partner for this to be a seamless experience would require deep back-end integration. But you know, Xsolla, we're all about solutions. So for the first challenge of diverse hardware and scaling, we are doubling down to improve on costs for our publisher partners, and these 3 capabilities from Streams helped with this. So the first was Streams offered us multiple virtual machine options with various hardware specifications, and that was important as it helped us to cater for games on multiple hardware specs. Second was cost optimization. We used the MASG, multi-application stream groups, for running many games from one capacity pool rather than running one game per stream. We also shifted to deploying on Proton as well. So both of these things help to optimize on costs and create customized pricing solutions for our publisher partners. And lastly, whenever we're expecting a spike in traffic, like at GDC or during game launches, or we needed to reach new regions quickly, with our implementation of multi-location stream groups, we could ramp up capacity and ramp in multiple regions really quite quickly. Solution number 2, getting to a feature-rich, seamless experience for our developer partners. Xsolla Cloud Gaming platform features are constantly evolving and requires substantial vendor integration and compatibility with our back end to be the best experience. So for example, may I borrow that? Thank you. This device, Xsolla implemented a custom virtual gamepad solution to enable PC games on mobile. The streams teams worked with us to ensure compatibility and seamless mapping of our implementation logic and their gamepad code, the perfect combination of a solution. This feature was requested by our publisher partners to enable them to go cross-platform. As mentioned, our publisher portal, Xsolla Publisher Account, allows for automated deployment of our developer partners' games. Through our deep platform integration with the Streams API, the turnaround time to game upload to deployment is greatly reduced. As an early adopter of GameLift streams, Xsolla Cloud Gaming and the Streams team, well, we grew up together, partnering through for nearly 2 years, not 10, 2 years, through thick and thin. We never really fell out, and we're really, really proud of this close partnership. So our deep integration and deep partnership allows us to better offer more diverse hardware to suit a range of a game's minimum and recommended specs, better user experience for product capabilities like virtual controllers, seamless and fast self-serve game deployment via Xsolla Cloud Gaming Publisher Portal. But what's most important to me and my team and for Xsolla Cloud Gaming is Stream's willingness to accommodate your future feature requests and rapidly address issues as they arise. I personally am incredibly proud of what we accomplished together on the first step towards the future of gaming. And thank you for the partnership GameLift Streams team. And I can see some of you out there in the audience. We love you. And thank all of you out there for your continued belief in the power of cloud.
Thank you. That's very cool. Thank you, Nilo. Okay, we got Asa from Ludeo closing us out.
Thank you very much. Hey, everyone. Super proud to be here. Show you the cool stuff we're building at Ludeo, how we're taking actually game discovery to the next level with the partnership we did with GameLift Streams. Before we'll drill down to what is Ludeo, how it looks like, how it works, let's talk about the problem that it's probably the #1 problem today in the industry. How do I discover games? Game discoverability becomes super hard right now. Just a few numbers, 19,000 games, new PC games launched at 2024, up 30% from last year. Conversion rates from impression, things that we're doing on social media, all the way the funnel to eventually download the game is less than 0.1%, and user acquisition cost increased in 50% in the past 5 years. So game discoverability became almost impossible right now, to discover new games, to launch a new game. And we believe that the #1 reason for that eventually has to do with how do we market games. So let's think about this for a second. We have our video game. We want to publish this. We want to promote this. We're mainly going to do that on social media because that's where eyeballs are. That's where potential clients are discovering content. So it's either us as publishers creating, several campaigns, trailers, or several ads, working with content creators, either streamers or VODs, or on TikTok, Twitch, YouTube, etc., or even our gamers just creating UGC highlights, clips, and sharing with their friends or with their communities on Discord. The problem is that when we're looking at all of these different actions, we eventually see that everything is being promoted through a video or a passive content. We're trying to promote an interactive content with a passive medium, which is video. And if we think about the journey our users or potential players needs to go through, from watching something on social media, probably on our mobile phone most of the time, passively watching something, and we know the rule of 7, we gotta see something 7 times to get us to the next level, and then we need to switch device, right? Go to the store on PC or console, download hundreds of gigabytes, or long time waiting, sometimes even purchasing the game, launching the game, registering as new user, going through tutorial, playing for several minutes, and only then I can really make a decision. Only after a few minutes playing the game, I can understand, yeah, that's a game I want to invest a few more hours playing, or nah, it's not the game for me. Now, knowing this in mind, this is the journey ahead of me. It's going to be very hard to take me from step 1 to step 2, let alone the rest of the steps. And what we see here eventually is every touch point, every click, every time we're asking our users to go through another step of the funnel, we lose them. We see churn. So what's our solution? We're basically tapping to the existing behavior. Publishers can continue to do trailers or video ads or ads on social media. Same for content creators, same for users. And they can promote that on different social medias. But now what they're doing, we're taking every video clip and we're turning that into a Ludeo. A Ludeo means that you're taking a video, you click on that, and then you can instantly play that exact same moment, even if you don't have the game. So the distance between watching something and playing something is literally sub-second. Think about watching the highlight of a content creator that you love. You watch that on YouTube or on Twitch or TikTok, and the distance between playing that exact same moment is just 1 click. So let's see how it works. This is a very cool game published by Krafton, the striking distance team, called Redacted. I'm playing the game, I'm in a level, I'm basically completing this flawlessly. I don't have any damage, so I consider this as a highlight. All I need to do is capture the hotkey, click the hotkey, I'm capturing the highlight you can see on the top left screen. I'm going to our creator studio, picking up the latest highlight, and quickly choosing objective. In this objective, on this trimmed moment, I killed 6 enemies. I'm choosing a few score parameters. I can trim that moment, and basically that's it. In seconds, as a creator, I've created a playable content that I can now share across any social platform. Let's take X. I've shared this on my X account, posted this, and now everyone who is discovering this on my feed or their feed are clicking on this, and sub-second, they can now actually play this moment. You can see on the left side of the screen, there's an objective. I need to complete the same thing that the creator did, so he's challenging me to do that 6 kills in 30 seconds. I can see a variety of games on the right, and eventually, you know what, I love the game, I click, and I buy the game. So that's end-to-end flow of Ludeo. Instantly drop into the highlights of other players. Could be your friends, could be content creators, or could be even a playable trailer. Everything that you want, every highlight of the game, the key features, we're taking them, or turning them to be playable. Now let's talk about numbers. We've partnered with Hitman a few months back. We decided to do playable, the first ever playable trailer. So Hitman promoted their DLC, their last DLC, featuring Jean-Claude Van Damme as the elusive target. Very cool, I recommend playing that. And that's what we saw. We've implemented in the gameplay scenes within the trailer Ludeos, and we saw 21% click-through rate from impression, from views on YouTube. Clicked and play Ludeo, and they've played that for over 5.5 minutes. So you take 30 seconds of engagement of watching a video, and we've basically multiplied this by 12, give or take. And they played 5.5 minutes, and then 20% converted to game install. That's the power of play, or the power of UGC, allowing gamers share their highlights and everyone to instantly play. So if we're looking at that funnel before Ludeo, right, a lot of steps, a lot of options to drop, a lot of places where I can just say, nah, I don't have the time to now go through the entire funnel. We've basically narrowed it down to, oh, yes, we have a have a bug here, but eventually took it from any awareness, any touch point directly to hands-on play, and then you go to the store. Just think it would be switched. So let's talk about the partnership with GameLift Streams. First of all, when we developed this technology, we immediately thought, okay, how can we make it the most frictionless as possible? We believe in frictionless, reducing friction as much as possible. So we looked for a cloud partner. We had several vendors of options, but we wanted three main things. One, we wanted a versatile team, a startup mentality team, a team that we can work very fast, or if we would need a new feature from that team, we wouldn't get the answer of, okay, great, it's in the backlog for 6 months. We want something and we need it now because we're a startup and we need a fast-paced team to work with. The second thing is that we want high level of customization. Our technology is not that intuitive. We need a lot of customizations to the underlying technology and the infrastructure. So we wanted a lot of customization possibilities. And the third thing, we wanted a business enabler partner. Someone that we can grow with, someone who can understand our business needs and can actually work with us on this. And then we found GameLift Streams, and very high level, I'm not going to go down into the details, but very high level, what we're basically doing is we have on our backend a very simplified version predicting what exact same highlights are going to be played in which regions, etc. And we know how to communicate with the GameLift Streams side of it, upload the machines. So eventually all of this together combined would be the sub-second experience, or the most frictionless and fastest experience to drop into a highlight of a game and play it. So let's talk about the future of our plans. Right now we've onboarded already multiple AAA studios, and we're now onboarding much more. So that's coming up next this year, which will cause us to basically support a larger scale of concurrent users and both games, regions, and users, and eventually improving the user experience even more, taking the time between click to play as low as possible, putting the cloud game as close to the users to create a better experience, eventually to become the go-to for gamers to discover games and download them. Thank you very much, and Chris, back to you.
This is the final slide. I think, just listening to what everybody's built here, it's actually pretty cool and inspirational, just the different directions and the capabilities that have been unlocked. It's really cool to see. This is live, right? So you can go home this afternoon and try Amazon GameLift Streams, upload your game, and start experimenting. You can also drop by our booth and try it hands-on. We have a bunch of games there you can see and feel for yourself. Like, what does it feel like to play a game that's streamed? We have a bunch of links here that'll direct you to getting started, and the launch blog, and to find out more. And with that, I just maybe one more round of applause for our speakers. Appreciate that. And I think that's it. Thank you for stopping by. Thank you. You got to go to the mic. Yeah.
Thank you very much for the session. I have two questions. The first one is, how does this compare to AWS AppStream? If I remember correctly, about 10 years ago, AWS also positioned AppStream as a game streaming platform. So why today I should choose GameLift over AppStream? What are the benefits when GameLift is more expensive than AppStream?
Yeah.
And the second question is also related to cost, right? So I think that what Jackbox game does is very interesting to me, but I believe they have the advantage of their 50 games have similar technical requirements, so you can do multi-tenancy easily. But what if I have a diverse portfolio of games? How do I deal with this tenancy? Can I do it dynamically? And also even adjust locality dynamically? Thank you.
Yeah, those are good questions. And actually we get how should I think about GameLift Streams versus AppStream semi-regularly? One way to think about GameLift Streams versus AppStream is GameLift is currently and will in the future be optimized for games. And there's special latency requirements and visual fidelity requirements and trade-offs that you make in a game versus streaming an application that would partition those two workloads. So that's a very coarse level of thinking about it. In terms of your question, how do I mix kind of different types of games? One that maybe is very demanding on the renderer and maybe one that isn't. You can do that with our stream groups. So you can kind of wrap your games into one stream group that are maybe low, demanding on the renderer, put those in one group and put your high demand games in another. And then you can share capacity across those two pools to minimize your costs. Yeah, those are good questions. Thank you. Yeah. Oh, we have another question.
Can you detect device orientation?
Device orientation, I think we can. Yeah. And we also provide source code for your virtual thumbsticks and other bits and pieces to get started. Yeah. Any other questions? We completely nailed it on the first. Yeah. All right. Well, I appreciate you all stopping by and enjoy the rest of your GDC. Thank you.